All right, everybody. Welcome to the first of three upcoming live virtual office hours that I'm going to have this week. So, today, obviously, if you're joining right now, you managed to find the right time despite me misscheduling it on social media initially. I am a one-man team, so unfortunately, between the email inbox and the calendar organization, sometimes things slip between the cracks. Nonetheless, a lot of you are already there, so some folks found it. But as I mentioned, because of the likely high impact nature of the weather coming up this week and the fact that it's going to affect probably all of California's major population centers, so both up in the Bay Area, in the Central Valley, and then also down in Southern California, LA, and San Diego metros, I figured this was a good week to have multiple live sessions. And so you're currently in the first of three live ones, and the other two that are scheduled right now are both going to be at 10 a.m. Pacific time, one on Friday morning and then again on Sunday morning. And I chose those times both as a function of my own schedule, but also maybe more significantly, the timing of the upcoming storms. So the first of the two major storms is due in tomorrow in Northern California, and then we'll slide southward into Thursday. In Southern California, Friday will actually be a break day in between these storms, so we can talk about the impacts from the first one, but probably a much greater focus on what is then looking likely for the weekend, because it is storm number 2, which is likely going to come in to Northern California on Sunday and then linger across Southern California Monday and even into Tuesday. That's going to bring the greatest impacts. So I do have 3 different live sessions scheduled. If things really go wild at some point, this would be more likely over the weekend. I might even throw in another unscheduled pop-up live session to do a radar and satellite tour if the higher end scenarios end up playing out. I don't necessarily think that's extremely likely, but it is possible given what some of the model ensemble members are suggesting, either for severe winds earlier in the weekend in Northern California and or very heavy precipitation and at least the potential for widespread flooding in Southern California later, really Monday into Tuesday especially. Those two scenarios they're not mutually exclusive, but the farther it goes in one direction towards NorCal wind, generally speaking, the less extreme Southern California rain we'll see, but you also could see a blend of both, or it really could hit one of those two things harder than the other. So I'll talk about that a little bit later. But I do want to talk first about sequentially the first storm in the sequence, which is due to arrive tomorrow, Wednesday. And this one's going to pack quite a punch too. This is going to be, and already is out there over the open ocean, a very impressive storm. This is a true atmospheric river, a classic moderate to strong atmospheric river according to formal definitions. It is also a Pineapple Express type atmospheric river, which is probably no surprise to people looking outside the day before a storm in late January and realizing that the temperature is in the 60s and 70s in California. It is not cold. It is actually very warm, verging once again for the yet another day, record warm in some parts of California. And in fact, this record warmth extends all up and down the west coast of places up in Oregon, Washington, British Columbia, and even eastward into Alberta have been record warm with temperatures in the 60s and 70s, even on the plains of Canada with this cycle. So really a remarkable turnaround from the extremely cold temperatures that we saw in these parts of the world just 10 or so days ago. In fact, there's some places in the Pacific Northwest that set some daily low temperature records just about 10 days ago and are now setting all-time monthly high temperature records right now. British Columbia has been hit hard not only with these warm temperatures, but also with a lot of warm rains from successive Pineapple Express type atmospheric rivers. And so there is ongoing flooding up there as a result of the combined rain, snowmelt, and warm temperatures. So this is not a good snow accumulation pattern for really anyone in the West yet. That may change a little bit as this pattern change wears on, but at least initially, and with this storm tomorrow, this is going to be a very warm storm. And there will actually be a warm front associated with it. So we don't always get well-defined warm fronts in California, and it looks like we're going to get one with both of the upcoming systems, where the initial frontal passage will bring even warmer and moister air before the trailing cold front, the more intense cold front, comes through and brings colder temperatures thereafter. So with the storm tomorrow, which again is going to mainly be strongest in Northern California, although it will hold together into Southern California and bring significant rainfall to the south as well. The heavier rain and the stronger winds with storm number 1 are probably going to be from about the Monterey Bay Area northward. So this will be a storm that affects the Bay Area during the evening commute tomorrow. So the timing will be pretty bad. Should be some heavy rains and and gusty winds up there in the Northern California and the Bay Area tomorrow. And so that may increase the impacts a bit because people really will be out and about. It won't necessarily be in the middle of the night as these systems sometimes are. So storm number 1 will be moderate to strong, nothing earth-shattering. It won't be any catastrophe, but it could cause fairly widespread urban and small stream flooding in Northern California. Conditions have been relatively wet recently, and this will bring pretty heavy rainfall in a short period of time. So there will be a period of heavy to very heavy rainfall, potentially associated with a narrow cold frontal rain band type feature that can bring half an inch or an inch of rain in an hour. So a good portion of what falls tomorrow could fall pretty quickly, and that will increase the likelihood of some flooding up in Northern California. Some of the smaller rivers may briefly approach or even exceed flood stage. We're not talking flooding on the Sacramento or San Joaquin rivers, but we're talking about rivers in Mendocino County, the Eel River, the Russian River, Sonoma and Mendocino, and maybe the San Lorenzo River in the Santa Cruz Mountains, rivers that respond quickly to short duration heavy rainfall when conditions are saturated. They could see some flood issues tomorrow. I don't anticipate them being particularly extreme, even compared to last year, where there was a lot of flooding in these same places, but it will be perhaps the most significant flooding of the season this year so far. And if the storm stalls out or there's a particular heavy rain band that gets stuck somewhere, there's always the potential for worse flooding, but maybe the more visible kind will probably be the urban and roadway flooding during the evening commute tomorrow in Northern California. That's pretty likely. Snow levels will start out really high with this storm. Again, it is a warm Pineapple Express type storm, so the initial precipitation will probably be as rain at lake level and maybe even at pass level, but the snow levels will fall though with the cold front. And there could be some significant snow accumulations, certainly at pass level and maybe down to lake level, although the way things have gone this year and the way things have gone in really the past decade or so, this is the kind of storm that I would be skeptical of snow levels being as low as models are suggesting right now in the mountains. So up at 10,000 feet at the top of the heavenly chairlifts, almost certainly going to get a big dump of Sierra cement. Not so sure about lake level. And below with this first system. There may be some snow, but there may be a fair bit of rain before the snow, and that isn't great for accumulation at lower elevations. Might be a different story with storm number 2, which is going to have a colder air mass both preceding and following it. So although the second storm will also be a warm storm associated with a warm subtropical atmospheric river, it will be one of those ones that also has some cold air lurking just behind it, and the air mass will be cold leading up to it. So with the Monday storm in the Sierra Nevada, there actually could be quite a bit more snowfall. That one has the potential to bring much heavier snowfall to lower elevations, even though the snow level profile with that second storm will likely be starting cold with some initially low snow levels, then warming and rising snow levels in the middle of the storm. But then on the back edge of that storm, when there will still be significant precipitation around, the snow level should crash and well below lake level. So there should actually finally be some decent accumulating snow down at 5,000 or 6,000 feet, but you might have to wait a little longer than the models are initially suggesting. That may happen primarily on the back half of the second storm due in later this weekend. And And the snow levels may be tricky with this because there is both some colder air to the north that's mixing into these systems, but also there's a whole lot of remarkably warm and moist subtropical air mass mixing into both of them as well. So it is that contrast between that warm subtropical air mass and the cold, drier air to the north that will help intensify these storms. So that is part of what goes into mid-latitude cyclonic intensification, is what's known as baroclinic instability, which comes from temperature gradients, temperature differentials in the atmosphere. So the fact that there will be unusually strong temperature differentials for California. So it's not just cold, it's not just warm, but there will be warm and cold air masses nearby and in the right position to allow for especially storm number 2 to really strengthen potentially as it comes close to California. So I think storm number 1 will mainly have significant impacts in Northern California. They won't be extreme, although Southern California also, this will not be a storm that falls apart before it gets south. There will be some heavy rain all the way down through San Diego and Los Angeles, with the usual urban and localized street flooding kind of stuff with the first system. Don't think there'll be anything too dramatic with that first storm, especially in Southern California. But there will be heavy rainfall and some urban and small stream flooding, probably maybe a couple smaller rivers up in Northern California tomorrow evening. And some gusty winds. I think there's some wind advisory level winds for gusts to 40 or 50 miles an hour with the first storm in the usual spots. That's nothing out of the ordinary for a winter storm in Northern California. But I kind of want to talk about storm number 2 because storm number 2 has a higher ceiling in terms of both rain and wind. Rain mainly in Southern California and wind mainly in Northern California. So that storm number 2, which again will probably approach Northern California on Sunday, and Southern California slowly may linger on Monday and Tuesday. So Northern California may get a quicker hit on Sunday, and Southern California might just get this thing that stalls out for a couple of days, which is part of where the concern is regarding the potential, at least, for some locally very heavy rainfall and more significant flooding concerns from late Sunday into Tuesday in Southern California. But with that second storm, it's still 5 or 6 days out. There's still some more uncertainty. But right now, what models are suggesting is that a surface low will develop right off the coast of California. And unlike many storms that approach California as they're weakening or maintaining their strength, the one on Sunday and Monday might actually be significantly intensifying right as it makes its closest approach. And that temporal trend, that strong strengthening signature as storms approach the coast, has historically been associated with some pretty high impact wind and flood events in the state. There is something about the fact that the conditions are right for a storm to strengthen rather than weaken, which is unusual. And is often a heuristic that suggests higher than ordinary level of impacts from these storms. So again, this is storm number 2 for this weekend that I'm now talking about. And right now, the models are suggesting that a pretty strong surface low is going to spin up as it approaches the California coast and slows down as it approaches the California coast, potentially. The American model, the GFS, has the surface low deepening from about 1010 millibars to under 985 millibars. So a 25 millibar strengthening of that low over a 24-hour period as it approaches the coast. We may or may not be hearing that term bombogenesis once again. We heard that last year. It refers to a rapidly deepening or a rapidly strengthening low pressure system. So essentially when the pressure in a low pressure system over the course of 24 hours deepens by a sufficiently large amount. And that number, by the way, is not a fixed number. Sometimes people call it 25 millibars in 24 hours, but it's actually the formal threshold is a function of latitude, technically. Nonetheless, whether or not it meets the official threshold in the end, 25 millibars in 24 hours is a big number for this part of the world. And more importantly than the absolute number, is the fact that this storm is going to do so close to the coast. So when we were talking about these rapidly strengthening surface lows last winter, a lot of them are occurring out over the open water, and they still managed to produce major wind and flood related impacts. But this one is going to be within a couple hundred miles of San Francisco when it does this. And so this has at least the potential to be a major windstorm for Northern California, for the Bay Area, and points really between about the central coast from San Luis Obispo north to about Mendocino. So that really is sort of centered on the Monterey and San Francisco Bay areas in terms of the potential wind impacts. There will be some very heavy rain potential up there as well, but it will be relatively brief. And I think the wind impacts, if the current model depictions are correct, will probably be greater than the rain impacts with storm number 2 in Northern California. The opposite is likely to be true in Southern California, where I don't think the wind will be particularly strong east and south of about Santa Barbara County. So it could be gusty, probably not an extreme windstorm for Southern California. However, the much bigger concern is the fact that Southern California could actually get 2 to 3 times as much rain as Northern California from the system number 2, and that is because of 2 things. One is this rapidly deepening surface low is going to allow the system to tap into a plume of deep subtropical or honestly even tropical moisture. I don't often say that in California, but there are some model solutions suggesting that the system could essentially have a moisture conduit going all the way down to about 10 degrees north latitude in the Pacific, and that is actually the tropics, not the subtropics. This is well south of Hawaii. So not just Pineapple Express, but I'm not exactly sure what we call these deep tropical moisture excursions. There may be a term for it that I'm unaware of, actually, but they're not common in this part of the world. That suggests the potential for Southern California to get a very rich plume of moisture, potentially even a record moist plume associated with this storm. And it might linger over some portion of either the Central Coast or Southern California for 24 to 48 hours straight. So it is possible that some section of the Central or Southern California coast between late Sunday and Tuesday sees a prolonged period of heavy to even very heavy rainfall sustained almost continuously over that period amid a very moist subtropical or even tropical moisture plume forced on shore by these winds associated with this surface low off the coast to the north. So that's a scenario that I've been watching for a few days, and right now the European model ensemble is more gung-ho on that very heavy rainfall outcome for Southern California than is the American model. Honestly, it's difficult to say which one is likely to win out, but right now the ensemble average from the European model is a little bit concerning in terms of how much water it's suggesting could fall in parts of Southern California between Sunday and Tuesday in particular. And again, this is following immediately on the heels of a more moderate rainstorm Wednesday into Thursday for Southern California. So conditions are already pretty wet in some places. They'll be completely saturated after the rain Wednesday, Thursday, and then an even more intense rain event is now likely to occur in Southern California sometime Sunday through Tuesday. And so I have some graphics I want to show, but I just want to emphasize that storm number 1 will be significant and is notable, but won't bring extreme impacts anywhere. Storm number 2 is a little bit more of a wild card, but it actually has a higher potential to produce some major and significant either wind and or flood related impacts, although the wind impacts are most likely up in Northern California, TBD, and the rain and flood impacts with storm number 2 are more likely in Central and Southern California. So from about Santa Barbara County all the way south to San Diego County being a potential risk. I would say there's about a moderate chance of significant flooding in Southern California, and a lot from the transverse ranges all the way south to the Mexican border, and south of it, by the way. The border doesn't magically stop these weather systems, and in fact the northern half of Baja California, including the Tijuana metro, is actually at significant risk of flooding as well, and that's a part of the world where there's actually quite a lot more vulnerability to these kinds of floods. So I did want to mention that as well. Of course, this potential for very heavy rainfall early in the week does not stop at the international border. I'm going to pause briefly to take a sip of tea. I am obviously feeling better than last week, but I am still recovering a little bit. and to look at some of the initial questions before I launch in and talk about the or take a look at the graphics themselves. So just hold on a minute. You might see an ad as I sip tea and read the questions, but you haven't lost the connection. I'll be returning in about 30 seconds to start talking again. So thanks for that, and I'm going to read the questions now. All right, thanks for that. And I did want to emphasize that there's a lot of questions today. It's going to be a busy week. I'm going to try and mainly answer questions focused on the storms that are going to occur right in the next week or so. So if I skip your question about something else, please don't take it personally. A comment that it is a very cloudy 70 degrees in Arcata, California. That is remarkable because 70 degrees would be a very impressive temperature in Arcata in, say, July. So to see it right ahead of a pretty significant storm in late January is just a testament to how warm this air mass is. This truly is a subtropical Hawaiian air mass moving into California with this first system. Question from Leland Bailey. When was the last time a cyclone bombed within 100 miles of the California coastline? Again, whether or not this storm will meet that definition or not remains to be seen, and I don't have an index off the top of my head of historical events, but generally speaking, all of the major very damaging windstorms in Northern California that I can recall in history coincided with a surface low that was both near the coast and rapidly deepening. So it isn't just enough to be near the coast, and it isn't just enough to be rapidly deepening. It has to be a rapidly deepening surface low that's actually close to the coast. This one sort of looks like it might fit the bill. This was true of many of the big windstorms in the 1990s and a couple of the big windstorms of the 2010s. The devil's in the details with these kind of systems, and so exactly how much wind and how deep the low and how close it's going to be to the coast when it does bottom out remains to be seen. This is something that the global models don't always resolve correctly because this is a classic example of something that's a fine scale process that high resolution models sometimes do a better job with. This is a case where what we call sub grid scale processes are important. So when the large scale global models are suggesting rapid deepening like that, then it raises eyebrows because it means that the finer resolution models might even suggest more extreme deepening once they get their hands on this. And it's still a little bit too far out. Most of the high resolution WRF runs and things like that, they run out no more than 2 or 3 days, and we're still 5 days out. So it's still in the territory of global models for now, but maybe by Friday we'll have a better sense of that during that office hour. All right. Yeah, and right now, I'm not going to get into the details in specific places what folks can expect. I'm sort of being deliberately broad right now because it's not fully clear yet. So I can be a little more specific later in the weekend or later in the week at least. Let's see. A lot of people reporting 70 degrees or close to it either today, yesterday, the day before. A lot of that going on. A lot of record warmth. There's been a lot of places that have hit new daily record highs in recent days in California, and again throughout much of the West. Let's see. Specific timing regarding storm number 2 is just too far out to be plus minus more than plus minus 12 to 24 hours right now. It's a very dynamic situation. We'll have to see how that evolves. But right now, these are sort of what it's looking like in the vague timings involved. All right, let's see. David mentions that the 18 Zulu GFS, which would be the most recent run of the American weather model for storm number 2, gets down to 975 millibars. Well, I'll be able to take a look at that in just a moment live. That's a significant further escalation. If that's true, I think it probably will meet the definition of a bomb. Now, granted, this is just one run. It's going to bounce around. You still want to have a better sense of what's going to happen until Friday or Saturday, but I'll take a look at that in a minute. Terry mentions it's 74 in southern San Diego. That's not quite so unusual, as you mentioned, down in far southern California, although it is, of course, warmer than average. It is a little bit more unusual because there are some big storms imminent. So if you get a big warm ridge in the middle of winter, then yes, it can easily be in the 70s and even the 80s in parts of Southern California. But that is usually not occurring in the warm advection of a winter storm. So that is what makes this a little bit more unusual. Yeah, a question from the LA Times about whether these storms are likely to boost the snowpack in the Sierra Nevada. Are these storms also forecast to boost the snowpack in the Colorado River Basin? It's a little bit of a tricky question. Right now, Sierra snowpack is right around 50% of average for the date. So it could be worse, but it is actually pretty bad. It's only at about 30% of the April 1st average, although I think the fairer comparison is average for late January, in which case it's about half. I think that we may actually initially dip down below half because it's so warm right now, yesterday, today, and tomorrow, and the initial storm will be the warmer of the two, producing rain even at some elevations that would normally have snow this time of year. So I actually think we may dip down to about 45% of average snowpack before that starts rising on the back half of the first storm, and especially with storm number 2. There's pretty big uncertainty regarding snow levels with storm number 2. I think with storm number 2 this weekend that the high elevations are going to make out really well and get several feet of really high snow water equivalent snow, which is going to help. So I think after this storm cycle it finishes up, and it's only going to last about a week, so it should be about done by next Wednesday or so. I think we'll be slightly better shape than we are now. So we're at 50 now, we may drop down to 45, and then we may get up to about 60, maybe 65% of average for early February by the middle of next week. I don't think we're going to get higher than that, so there's still going to be a significant snow water deficit even after these very wet storms because A, they will be affecting the coast more extremely than the mountains. Once again, that's been a theme this winter, but also that they aren't going to be extremely cold storms. So, there will be, these are both, the first one is a literal Pineapple Express type atmospheric river, so it's starting out warm. And the second one will start out cold, then have a really warm nose in the middle of it. And we'll just have to see how much progress that warm nose makes. Sometimes the cold air surprises us, and cold air damming up in the mountains, things like that, keeps snow levels lower than the subtropical air mass might suggest, and you get a huge dump of snow at lower elevations. But sometimes that subtropical air really leaks in and causes that snow level to continue to stay higher than we had hoped for. So, there will be large snow water equivalent gains above about 7,000 or 8,000 feet. What's less clear is what's going to happen between about 4,000 and 7,000 feet, where there's a lot more land in California, and that will sort of dictate how much SWE recovers in the coming days. So it's not totally clear. The overall water situation will be better, by the way, after the sequence. In fact, if the current predictions hold, most of Southern California may end up above average for the entire season, based on the precipitation that could fall, that has already fallen, plus what may fall in the next week, which is remarkable and would mean that the tilt in the odds towards a wetter than average winter would potentially be verified just by this storm sequence alone, regardless of what happens the rest of February and March in some parts of the Central Coast and Southern California. It may well be that there's too much of a good thing, as I've been talking about. The risk of significant flooding in Southern California in particular is rising for Sunday through Tuesday. Feast or famine, it may be a bit of a feast, or a little bit too much of a feast earlier in the week in terms of water. But again, this speaks to this notion that California could well see an above average precipitation season and a below average snowpack in the same season. And this is going to be a signature of wet years in a warming climate. It's getting warmer and it's getting harder for that snowpack to accumulate at lower elevations, even though it still does so pretty well up at 8, 9, 10,000 feet. So we will see. Colorado River Basin, again, this is a good amount of water. It may not be a cold enough storm to produce really good accumulations across the broad areas. Again, at very high elevations, at 10,000 feet in Colorado, there's going to be good accumulations this week. But this isn't a super great snow accumulating pattern at medium to medium high elevations, actually. It's just a little bit too warm for that. Plus, storms that bring a lot of water to California are not always the storms. In fact, they often aren't the storms that bring the most water to the interior west. So you wouldn't necessarily expect a really wet California storm to necessarily produce all of that water and the snow in the mountains in the interior west, because often California removes a lot of the water from the air mass. So by the time it makes it to this is why the Great Basin is a desert relative to much of California, by the way, is that by the time these systems make it to the east side or the leeward side of the Sierra Nevada, a lot of that moisture in the atmosphere has been squeezed out by the topography along the west coast, and there isn't as much left to work with further east. And as I mentioned, the April 1st snowpack is, it's hard to predict, but I would not be that surprised this year to see an above average precipitation winter in central and southern California. So over 100% of average, maybe well above 100% of average if we get another storm cycle like the present one, and also see snow water equivalent that's, 60 to 70% of average or even less because of how warm it has been and how much these storms have favored the coast rather than the mountains. And a question about why that is, why the storms this year have brought so much more rain versus snow. How much of this is El Nino versus climate change? I mean, the main reason that the snow line is creeping up the mountains is climate change, full stop. It's getting warmer. This particular year, El Nino sometimes tends to bring more southern branch storms than northern branch, and so we get a little bit more of a subtropical influence sometimes, and so snow levels tend to be higher. But generally, historically, El Nino winters weren't that much warmer than other winters in California, but now they are. That's climate change. So I think the main reason why we're seeing worse snow years, even in years where we're getting a lot of water sometimes, is because of the long-term warming trend associated with climate change. Partitioning that out is a little bit tricky, but that long-term warming trend is doing the lion's share of the work there. I mean, that is just the way it is, unfortunately. All right. Oh, Aaron asks, is there a strong thunderstorm threat for Southern California during the second storm? There probably will be some thunderstorms embedded in both of these systems, storm number 1 and number 2. The second storm might have higher potential for some localized severe weather, producing maybe some severe wind gusts associated with some of the thunder cells up in Northern California if that low bombs out, and maybe some torrential downpours in Southern California if some of the higher end scenarios for Southern California play out. And that's concerning because those are the kind of events that result in the most damaging debris flows and flash floods in Southern California. So you can get a lot of urban and roadway and small stream flooding no matter what. But if you get those localized torrential downpours, as we've seen this year in Ventura in December and in San Diego just last week, you can get really serious floods locally. And it is possible that we see a third round of something like that somewhere between Santa Barbara and San Diego with the storm number 2 in particular. So that is a possibility. We'll have to check that out a little bit later. That'll be a little more apparent this weekend. All right. So I am going now to swap over. You're going to see my face disappear. I'm sure that's not a disappointment for anybody, but I'm going to bring up some weather maps, and I'm going to start off with... Okay, good. That's showing up nicely on the screen. what you're seeing now, and let me make sure that it's refreshed since their webpage was having some problems earlier today. This is a live view of the actual, this is storm number 1. And it's churning out there over the Pacific Ocean, and it looks frankly impressive. I mean, that is just in fact, I might want to save this image because that is just a classic mid-latitude baroclinic cyclone. Obviously, the center of circulation is out here, about the same latitude as the California-Oregon border. This surface low is not going to make it into California. It's going to spin northeastward and make landfall up in the northwest. But it is this trailing cold front and the associated atmospheric river. Hawaii is right down here. Or sorry, Hawaii is right here. You can see, I think just that's Kauai on the northern end of the island chain right there. You can see that there is this plume of moisture that extends and getting entrained into the system, going all the way back to the northern Hawaiian Islands. There's a very well-defined cold front with a nice, this may even be a little bit of a baroclinic leaf-type cloud developing in this area. It's a little bit of more of a mature cyclone, so maybe that's just some jet force cirrus there. But anyway, there's a nice well-defined cold front in there somewhere. There's a nice plume of subtropical moisture going with this Pineapple Express system all the way back there. This surface low is going to go somewhere to the northeast, but this whole big mass of clouds is going to roll right through California. As you can see, it extends plenty far south. The whole state's going to get wet from this one. It's not going to skip Southern California. So California right now is sort of mostly sunny to partly cloudy skies amid sort of a warm and even maybe slightly humid air mass. That's sort of true all the way up here, where this whole region is seeing much above average to locally record warm temperatures. Again, this is unusual because this is not a strong ridge right here necessarily. This is in the warm sector. So there's a warm front, a weak warm front sort of arcing like this, sort of classic form, and there's a cold front here. All that warmer, moister air coming up from the south into California right now. So this is what you see today. The Sunday storm is probably going to look smaller but tighter and maybe more impressive, and it's going to be much closer to the coast. So you see the surface lows out here with this storm. The surface low on Sunday is going to be right about here, so you can see why I'm more concerned with some higher potential for impacts then. All right, so one thing I want to focus on first, and this is, let's see, so this actually, since I've been talking, this most recent model cycle updated with the GFS. So let's take a look at what this system might look like. So this is tomorrow's storm. And this map, by the way, is wind speed in nautical miles per hour. It's about 1.1 miles per hour. That's an awkward unit. It's traditional. Just think about it as miles per hour plus 10% essentially. And so yeah, it looks like, you know, these are pretty strong. Some decent wind gusts tomorrow in the windier parts of the Bay Area into the 30s and 40s miles an hour. Nothing, you know, extreme, but definitely, you know, a notable windstorm. Winds weaken somewhat once they get past the central coast. Winds down in LA and San Diego will be breezy, but nothing really to write home about with this first storm. What I really wanted to focus on, this is as we get towards storm number 2, so you can see we're going into Sunday. This system is going to be coming from the southwest, or almost south to north, southwest to northeast. And look what happens. There's some strong winds. This is early morning hours, just after midnight on Saturday, early Sunday. This is early morning on Sunday, this storm. This is, again, the most recent GFS, so I'm seeing this as you're seeing it. It's brand new. These are surface wind gusts, and so already here, there's some 50, 60 knot. That's 55 to 65 mile an hour gusts with this system out over the open water. And let's see. Okay, so this is the next frame. This is mid-Sunday morning. And as you can see, this is starting to get up into some unusual territory. Now, you know, again, these are not winds at higher levels in the atmosphere, but these are surface wind gusts, so nautical miles per hour. You can see that with the GFS in this run, there's some winds above 60 knots, even getting close to 70 knots. So 70 knots is about 75, 77. Well, sorry, it's about 77 miles an hour. So right now, this is showing 70 to 80 mile an hour wind gusts west of Monterey and Santa Cruz counties over the open ocean. Let's see what the next frame brings. And some of this is because as the system moves up the coast, wind speeds over land always get attenuated. This is showing the Monterey and San Francisco Bay Areas being hit quite hard up into Mendocino County with winds. This is still showing explicitly something like 60 knot or 65, 70 mile an hour gusts. And again, sometimes you get stronger gusts than the average gust over exposed points along the coast up in the mountains. So to see a widespread region of 60 to 70 knot winds with this storm potentially at the surface, it suggests that there could be a pretty major windstorm. You can also see some stronger winds this time, not quite as strong as Northern California, but still stronger than the first storm down along the central coast. So these are winds up in the 30s and 40s of miles per hour. So that's, again, not extreme, but notable. And you can see this system, it sort of slows down as it approaches the coast. So this could be a pretty long duration, strong wind event from late Saturday night into maybe the early hours of Monday in Northern California before things taper off. It looks like it'll still be breezy. In fact, this GFS is essentially showing this low stalling out, weakening a bit, but stalling out on Monday near Northern California and remaining breezy, although not nearly as windy near the Bay Area. In fact, this low stalls and then starts to move back south. Wow, this is quite the scenario. So by Tuesday morning, the low is now leaving Northern California and is going to take an approach swinging southward outside of Southern California. So that is quite the trajectory. Again, this is just one model run. Let's see what this looks like in terms of let's see, this is not quite what I was looking for here. Okay, so here's what the precipitation would potentially look like. This is that first storm. Let's look more at the second storm. So, okay, so you can see, this starts out with reasonably low snow levels, but things get warmer as the storm goes on. I see what you mean. The GFS does have this bottoming out in the mid 970s millibars. It is a very strong low. In fact, that might actually be approaching some of the low pressure records for February in this region. We'll have to see. And then it sort of fills in. But notice that the Bay Area, despite the really strong winds, doesn't get a huge amount of rainfall from storm number 2. But look at what happens in Southern California, where this frontal band kind of stalls out for a prolonged period of time, again, somewhere between Santa Barbara and San Diego County. I wouldn't take this too literally, but just to see how much precipitation falls in total from this second system. This is highlighting maybe not the best thing to highlight right now, so I'm going to go away from this. But here is, let's see here. Let's take a look at what the European model ensemble. So this is the different model. This is instead of looking at one individual model member, this is now the entire ensemble average, just accumulated precipitation. So this is essentially showing, this is the storm number 1. And I'm using the European model because it has the slight edge on the GFS, usually. So this is what you'd see after following the first storm. Again, pretty decent totals in the Bay Area, 2-3 inches, looking pretty common. North Coast a little bit higher, maybe up to 4 inches. Central Coast up to 2 or 3 inches, and then coastal Southern California mainly 1 to 2 inches from the first storm. So not a bad storm in its own right in a part of the state that sometimes only sees 10 or 15 inches of rain a year. 1 to 2 inch storm is nothing to sneeze at, but isn't all that extreme. But then this is what we start to see as we head into Sunday. This is sort of, you see things escalate again with storm number 2. And notice how conditions, as we go into Monday and Tuesday especially, really ramp up along the central coast and parts of Southern California. So this is a 10-day total, but keep in mind that most of this would be falling from the latter half of storm number 2 in Southern California. Look at these values down here. Really from about Orange County into Santa Barbara County, especially right below along the transverse ranges. A lot of numbers up in the 7-8 inch range here. So that's a pretty large number for average. It's down a little bit actually from what we were seeing earlier. So maybe that's a little bit of good news. But one thing, this is the ensemble average. So as if you have two values, if you have one model that says you're going to get an inch of rain and another model that says you're going to get 20 inches of rain, an average of 10 doesn't really tell you what's necessarily going to happen. An inch of rain, no big deal. 20 inches of rain is a catastrophe. So what do we actually see in the ensemble distribution? That's what you're seeing now, which is, again, I've shown this plot before, but I'm showing it again to illustrate something. Again, that ensemble average, this is for a point near LA. The topography is smooth, so don't take this too literally. This isn't saying that it's necessarily going to be 7 inches of accumulated rain at the beach just west of the runways at LAX, but it is saying that, in the flatlands, the pretty high numbers are plausible. So the average is up around 7, is total accumulation from both these storms together around 7 inches for a point near LA. That's a lot given that Los Angeles, at the same point, depending on your observation site, sees between 12 to 15 inches of rain a year. This is a significant portion of the annual average. But look at these individual model members above. And I've shown this before, this plot. This is for the European model ensemble, and there's 51 different members. You see them each in a horizontal line, each of these showing different potential plausible accumulations of precipitation between right now and February 14th. As you see, the line, it kind of flatlines after about the 7th of January or the 8th of January. So most of this water is falling, the 8th of February, I should say. So most of this water is falling early in the period. There's essentially nothing new happening after this point in the graph in most of these. So it is this period between about 2 and 6 inches that's going to be of most interest. Look at some of these individual members. So there's a few members that are as low as about 3 inches of rain or so. But that's notable that the very driest members of 51 model members from the best performing model around LA show the very driest member is 3.1 inches over the next. So that's a pretty significant amount of rain. But there's a lot of members that are up in the 6, 7, 8 inch range. Look how many of these end up 6, 7, 8. And look what the very highest numbers look like. There have been a few individual model members, and I've been highlighting this for a number of days, showing really high numbers like 10, 12, almost 13 inches. And that is not a likely outcome for Southern California. And I would say that the odds are somewhere between about 5 and 10% based on how often we've been seeing it. But this would probably occur if there were a secondary frontal wave that develops, if that deep tropical moisture just trains over the same area for 48 straight hours and just dumps torrential rainfall. Again, that's not super likely, but there continue to be individual model members. I mean, look, there's a 9.7, a 9.7, a 9.2, and 12, some 12s and 10s in here. 5 to 10% of these members are extremely wet and would cause major flooding throughout Southern California. So the average, the median number is pretty significant and is likely going to result in significant flood concerns regardless. So I would, at this point, I think it's time to be thinking about that. But some of these individual members would cause a much greater flood problem and would really cause quite severe flooding potentially. So again, it's only about a 5 to 10% likelihood. But then again, 1 in 10 is not that small of odds. It's one of the reasons why I'm going to have a few different updates over the next few days to follow this. But suffice it to say that there will be some flooding in Southern California, and if almost any of these come true. So there is a almost 100% chance of some flooding. The question is whether it is pretty unremarkable street flooding and urban flooding as we see during almost any major storm in a part of the country that has a lot of paved and impermeable surfaces and freeway and parking lot space, or whether it's something considerably more significant than that, which would be the case for some of these model members that are showing upwards of 8 and 9 inches of rain over a relatively short period of time in different parts of Southern California. Again, this is just a random point from the model. There are probably places that it would have both higher and lower numbers than this, but it is representative of the fact that some of these scenarios where you have very moist plume of tropical moisture combined with pretty strong storm dynamics. At least in the model world, you tweak a couple of parameters and you can get a pretty extreme rainfall scenario, or you tweak them in the other direction and you get what is essentially a much more ho-hum type scenario. So the most likely outcome though is it's inching up there. I mean, again, these are the average values, and those are pretty high. So we'll just have to see how that develops. Still sort of in wait and see mode, but it does look very wet in Southern California, particularly from LA County into Ventura County, which are places that have been hit really hard already this winter. And so I would expect that Ventura County, Santa Barbara County, maybe LA County, maybe SLO, are all going to be, above average for the entire season by the end of the storm cycle. I think that's pretty likely at this point. The question is whether it comes with major flooding or not, and that remains to be seen. All right, so you're going to see my face again. Bring that back, see what's going on here. All right, let's see what the new... Oh, didn't actually do that. Here we go. Okay, and now we're getting close to the hour. I'm going to take another sip of tea and going to check on the questions and comments and try and get through them in 5 minutes. So more tea and more reading. Bear with me. A question from Vanilla Sky. What about the saturated ground in San Diego? People are still cleaning up from the floods. Yes, this is a concern. I don't think we're going to see necessarily the same kind of extreme hourly rainfall rates in San Diego. This most likely looks like the really heavy rain potential in California might be centered somewhat to the north, so more like Orange County or even Orange County or Los Angeles County northward. So the slightly more northerly part of Southern California. That said, there still will be heavy rain in San Diego, and that could be a problem given that, as you mentioned, people are still cleaning up from floods. And there's a good chance that there will be new floods as well in different places. And I wouldn't rule out flooding in San Diego from this event either. I just think that the very highest likelihood is probably between western Santa Barbara County and Orange County with this event. All right, let's see here. A question from Daniel, a basic question. How come this is called a cyclone and not a hurricane? The reason for that is that meteorologically speaking, hurricanes are, it's exclusively a term used to discuss, I'll just start that again for the soundbite. The reason why we don't call these kinds of powerful winter storms hurricanes when they spin off the California coast, even though they can sometimes look visually somewhat like a hurricane and have eye-like features and spiraling bands of rain and wind, is because hurricanes by definition derive their energy from warm tropical oceans through latent heat fluxes from the surface of the ocean itself. Fundamentally, that is not how winter storms form. These storms that we're seeing, the one you see on satellite for instance, derives its energy from horizontal contrasts in temperature. So temperature gradients in the atmosphere. Baroclinic instability, it's called. And so in that way, these storms are fundamentally structurally different than tropical cyclones. Tropical cyclones usually occur where there are almost no temperature gradients in the atmosphere. Think about, tropical ocean regions. You don't have big cold fronts. There aren't big differences in temperature from place to place. You go a few hundred miles and it's maybe just a couple degrees warmer or cooler than it was a couple hundred miles in any direction in the tropics. There aren't strong temperature differentials to drive baroclinic cyclones, mid-latitude winter cyclones, whereas there is enough energy in the oceans under the right conditions that tropical cyclones can extract that energy directly from the warm ocean. We're talking about ocean water of like 80 degrees or warmer Fahrenheit to support hurricanes, which is one of the reasons why California does not actually see hurricanes. Generally speaking, the ocean is just too darn cold. So you can talk about hurricane force winds. Occasionally you'll get an extratropical, non-tropical meaning not a hurricane, cyclone that can have winds of hurricane force. So if you get sustained winds of 74 miles an hour or higher in a winter mid-latitude cyclone, it kind of might have the same impacts as a hurricane in some ways, but it isn't a hurricane, meteorologically speaking and structurally speaking, and usually the ceiling on how intense mid-latitude cyclones can become is lower. So you can see in a very intense hurricane or tropical cyclone in the places of the world that are most susceptible to them, hurricanes can attain sustained winds of 150, even getting close to 200 miles an hour in the most extreme scenarios. You do not see mid-latitude cyclones with sustained winds of 150 to 200 miles an hour essentially ever. And it's simply because sometimes there is just so much energy concentrated in extremely warm tropical oceans that you can actually generate and sustain a storm of that incredible magnitude. You generally can't get enough baroclinic instability to generate winds of those very extreme magnitudes, partly because the pressure gradients, the storms themselves are larger. So you might have a similar pressure, but the gradient is less because the storm essentially is spread out over a much larger area for winter storms than it is for tropical cyclones. So you might have a tiny, in relative terms, tropical cyclone that only expands over a couple hundred miles, has a very narrow inner core, say 5, 10, 20 miles wide, where you get almost 200 mile an hour wind gusts. But if you're 50, 60, 70 miles from the storm center, you're just getting a tropical breeze. Whereas with a mid-latitude cyclone, you can be hundreds of miles from the storm center and still be getting 50, 60, 70 mile an hour wind gusts. So you sort of trade area of fairly strong winds for a much more limited area of extreme winds and tropical cyclones. So they're both different in how they form, different in structure, and therefore they tend to be quite different in impacts. Although there can be some overlap between the strongest extratropical cyclones and the weakest hurricanes, essentially, is one way to think about it. All right. Let's see here. Oh, yeah, sorry. Steve mentions that back when I was showing that wind graphic, the scale was apparently cut off on the version I was sharing. I was verbally describing the wind speeds associated with it, but just to summarize, the most recent run of the GFS, which again is just one model, one run. We'll see if that holds. We'll see if it trends upward or downward from there. Was showing wind gusts over the open water west of the San Francisco Monterey Bay area of 70 to 80 miles an hour. So that's pretty significant and is a suggestion of the potential that this could be a major windstorm for parts of Northern California. All right, continuing to scroll down, see the comments here. Let's see. All right. Continuing. Okay, the last thing I wanted to close with, and actually this is a good reminder, and I talked about this in the last call, and again, I don't really want to give it much more oxygen, but because the messaging is now very confusing, because there are a couple of significant, and maybe one more than significant storm coming for California in the next 5 days, is that, again, this is not an arc storm-like scenario. This is not anywhere near the level of rain, sustained intensity of rain or flood risk that we would see during a multi-week extreme storm sequence conducive to something approaching an arc storm level event. In fact, right now, it looks like that most of California will probably get a break in the rain in Northern California starting on Tuesday, And in Southern California, starting by Thursday next week, that might last a while. So I think we're actually going to get sort of a 1, 2, maybe 2.5 punch, depending on whether there's a secondary wave in Southern California. And then it will stop for a while. So this isn't going to be sustained indefinitely. There might be another major sequence to come later in February. It's not even February yet. It's only January 30th. So or in March. So you never know what's coming down the pike in a few weeks. But some of the folks who continue to claim online that the arc storm is imminent out over the Pacific are just wrong. And there was never an indication that it was. There still isn't an indication that it is. I promise you that I would tell you if it was actually coming. And despite all of that, there is some flood risk in California over the next week. And it could be significant flood risk if some of the higher end scenarios pan out, particularly in Southern California. I don't think there's going to be major flooding in Northern California. There will be some stream urban flooding at times in the Bay Area and along the North Coast, but probably nothing too extreme. Southern California will definitely see urban and roadway flooding, probably with both storms, but especially with the second one. And depending on how things go, that storm number 2 in Northern California on Sunday could produce a pretty severe windstorm. Stay tuned for that. And in Southern California, Monday through Wednesday, could produce widespread and potentially significant flooding beyond just minor nuisance flooding, depending on how that goes. It would likely be concentrated in a 1 to 3 county area somewhere between Santa Barbara and San Diego County. It's too difficult to pinpoint yet, and we're not sure. Which is why I'm going to have 2 more live sessions. The next one, Friday, 10 a.m. Pacific time, and then the following, Sunday, 10 a.m. Pacific time. And who knows, maybe there'll be another one mixed in. But for now, I think I'm going to log off. I'm going to add a link to the most recent Weather West post in the chat right now. So I'm actually going to include that while I'm still talking, so you can go navigate over there. Everything I said yesterday is essentially still true. Feel free to check that out. And I think with that, I'm going to call it an hour. I'll be following this, and keep an eye on the satellite imagery. It's looking awfully interesting out there. So I'll try and post that on social media as well. Thank you, and talk to you on Friday morning.